Okay. Hi everybody. Rich has left me some, oh, hang on, can we turn the lights down a bit? Dim down. That's better. So, Richard talked to me last week and told me what he wanted me to do, and then he got really sick, so. Well, where are we? Course schedule. Is this the right one to go to? Okay, you guys have to help me here, because you know how this is set up better than I do. So, let's start from the beginning. And what it says, Chutes and Labs. Okay, I managed to put the Chutes and Labs up, and revision. Please extend every courtesy to Tim. Curtsy. Nope, curtsy. Okay. Guys, I want to see a curtsy. No. All right, so I'm Tim Lambert. I'm going to be doing the lectures 1, 2, 3 this week, which is going to be about the stuff in the course, and then Malcolm Ryan is going to give the extension bonus lecture, 4th lecture on Wednesday, and he's just going to talk about fun stuff, whereas this stuff I'm going to talk about work stuff. And what else has he said here? Hard to stead this up into someone else's course, yeah. I've got to step into Richard's shoes, and as you know, he's got really big shoes, like clown shoes, and it's tough, so be nice to me, or I'll cry. Or beat you with a big... Did he show you the video? Okay, so he tells you how caring I am after showing me a video of me beating up a student. Anyway, you should be intimidated. So, schedule, and then we go down to here, and this is us. This is us. Arrays, and I click on Richard's. Stop me if I'm going wrong here. All right. There's our bullet. Ooh, we've got about 4. Okay. So that's what he left me. Also, it's also on a piece of paper. So that's my plan for this week. And we're going to start with, what's that say? Calculate average. So here's the deal. I want to write a program that calculates the average of a bunch of numbers. Not too hard. I think you did something like that in a tute exercise, except it was the average of 4 numbers. Does that sound familiar? Okay, well that was pretty lame, because really you probably don't want to just do the average of 4 numbers. You want to do an arbitrary number of numbers. And now we know the power of the while, we can do it. So let's start with, hang on, computer, and that's good. No, not good. Why are there 2 inputs here? Hang on. Let's go computer. That works. Laptop. No input. Which? Yeah. That's not me. Hey!
Just in case you're moving the thing, it needs to slot in properly. Just tight.
Should I try the other cable? Oh, that is the other cable. Maybe it's unplugged here. Right. Always carry a spare video cable. So, what was I trying to do? I was trying to write a program to calculate the average, so, of a bunch of numbers. So let's go, hang on. We'll call it average.c, sounds like a good name. And, yeah, I guess I should make this bigger, hang on. And, is that big enough, or do you want bigger type still? Yeah, bigger. Bigger. Courier 18. Oops. No, that hasn't changed. Hang on, shift. Courier. Let's go for 18 bold. That good? Or do you want it bigger still? Ah, geez. Bigger still. Hang on. Shift, click. Courier. Whoops. I didn't even mean to do that one. Lucida Sans typewriter bold 24. That's 24. Sound good? All right. So, I'm going to write a program with average.c to calculate the average of a bunch of numbers. Shh. And just to get started, because I'm lazy, I thought, why start from scratch? That's one Richard did last week, which had a while loop in it. I don't remember exactly how while loops work, so here's a good way to write programs. Start with a program you've already written that's vaguely similar to what you have to do, and we'll just change it around. So this was last week's count the number of E's as an input, and now we want to, what are we going to do? Average. Average of the input numbers. Okay, so where instead of having cipher character, what are we going to do? We'll call it, what do we call the number that we read in? Think of a name for it. Pardon? Dividend. No, that's, we're going to read in like 5, 6, and 7 and average them all up. So input, pardon? CNUM. All right. CNUM. Why CNUM? But what's the C stand for? Current. Current number. All right. Sound good? And we're still going to have to count the number. Why double though? I'm going to use an int just to be different. We're going to count the number of things we read in, and in order to work out the average, what else have we got to keep track of? That's a count. The count will count how many numbers you've read in. What's the form of the average? Yeah, the sum of all the numbers divided by how many there are. So we want to call it sum. That sound good? So change the variables there. Always good when you do this sort of dodgy thing to change all the variable names, unless you're sort of using them again, because that way we'll notice when we get things wrong down here. Okay, now what else we got here? Before we had get car, because we were doing characters. Now we're doing nums. What do we do for nums? Get num? I don't think so. Scanf. So to read in an integer with scanf, it's something like this. %d, is that right? D. We're going to do integers. So scanf, and we give it cnum. How's that? Ampersand, right. Oh, yes. It's not going to work otherwise. So there we go. Read in the number. And, oh, while. Oh. So before we said while not equal to end of file. The character is not equal to end of file. We've got to do the same thing now for reading in numbers. And that's when I go, I know, read the manual. Let's go here, and if I can remember how to change the font. Where does it say? File is ready. Where's the font here? Ah! So, there we go. Nice big font. Man scanf tells me all the things it can do. Let's see, what does it say? Format, blah, blah. How do we detect if we got to the end of the file using scanf? We know how to do it with getChar. Oh, it's so long. I hope you guys are reading this. Return value. Ah, there it is. What's that say? The value EOF is returned if the end of the input is reached. That sounds good. So, let's go back to my program here and go, I don't know, return code we'll call it. So we'll do a scanf and save it before. The one with the count the number of E's, we used the same thing twice. We were able to use the character returned from getChar, sort of did two things at once. It told us whether we got to the end of file by having the value EF, or it told you the actual character. We can't do that with numbers because any possible number could be input, whereas with characters you could use this special int value. So I gotta have a separate thing. So now it's while return code. There it is, it's not equal to end of file. And now is alpha, oh, we don't need that. Let's get rid of that. But we do want to count them, right? So count, add one to count, and what else do I need to do?
Sum equals sum plus.
Yeah, sum equals sum plus. We've got to add the thing we got to the sum. And what did we call it? CNum, current number. There we go. All right. And, oh, I guess we've got to change that. What's that going to be now? Reading the next number. Yeah. It's just this line up here again. I don't need to declare it again, do I? Okay. This is good. We've changed almost every line, but the old program made it easy for us because it provided a framework we could use to write this program. Assert letter count bigger than 0. Well, we now called it count, so we've got to do that. And now we've got to do the averages. So, average is, and now it's going to be, instead of e count over letter count, hey, it's total, no, sum. Sum divided by count. There we go. So let's save that. Go here, quit from here. Am I in the right place? There it is, average.c. So what is it? GCC wall. Oh, we've got to do where. All right, we're going to be good here. There we go. And we're going to output it to average. And all right, does that look all right? See what happens. Oh. Warning, format %lf expects type double, but argument 2 has type int. Well, if we don't understand it, at least we know what line it's on, line 17. And conveniently enough, I'm on line 17. Format expects a double, but what have we done wrong?
Sum and count are both integers.
Right.
When you divide them, your answer is also going to be a whole number.
It's also going to be an integer, and the format says it should be a double. So I guess there's two ways to fix it. We've got to make them match. We can change either the format to match, or we can change the type of the expression to match. Which is the right one? What should we do?
Change the variable because the answer to averages is
Oh, right, yeah. Did everyone catch that? Averages aren't necessarily whole numbers. If we take the average of 2 and 3, the answer is 2.5. So if we made the type different, we'd only get an approximate average. So we should make this thing different, in which case, so what do I do? Cast it to a double, like that?
No, that won't work.
Why won't that work?
Because it will make it a double after it's done with division.
All right. If we do the division of two integers, the result will be integers. So we do 5 divided by 2, we'll get 2, right? And then we'll turn it to a double, 2.0000. It's still the wrong answer. So to make the actual thing work the right way, do it in there. Okay. Oops. Let's try it again. Okay. Hasn't complained. Let's take the average of 4 and 5 and Control D. Ooh, worked. What other tests should we do? Try some different numbers. All right, so what do you want to do? Not sure that's going to work because we said integers.
Yeah, but it doesn't say that in the spec.
Well, that's what I meant. Oh dear. Nothing's happening at all. I hit Control D and yeah. It's gotten stuck on this. So we should also try putting nothing in. But what's gone wrong here? It's not even giving me an answer. I press Control D. It's just stuck. It's doing nothing. Pardon? I've pressed Enter. I've pressed Control D. Control C. It didn't produce anything. Oh, do you know what went wrong?
Oh, it's because it reaches EOF if you type a result that it can't accept because it wants an int and you give it a double.
Yeah.
So it reaches that EOF straight away.
Well, in that case, it should have given me an answer, though. All right. Count isn't incrementing. Yeah, I don't know. Maybe we'll... I'm going to just put a print in here to see if I can figure out what's going wrong here. So we'll print out... I'm just going to print out... yeah, current value is sum. How's that sound? Maybe we should print count as well, but let's see what's happening. Actually, we should do it after we update it. There we go. So recompile it, run it. Now what went wrong? We said 2.5 and oh. Well, that's interesting.
Come on!
It's already counted up to 3 million. But look, it's adding 2 on each time. So we typed 2.5, and then some went an infinite loop adding 2, 2, 2, 2, 2, 2, 2, 2, 2. So we're on the right track. We added 2 onto the sum, except we did it again, and again, and again, and again, and again, and again. Boy, it's easy to write an infinite loop, isn't it? Can we figure out this mystery? Look at the program again. What we did was we gave it something that wasn't an int. We said 2.5. So guess what scanf does if it sees something like 2.5 and it's trying to read an int? It read in the 2, because we know we're adding 2 to sum. And then for some reason my program went into an infinite loop. What can we do to try to figure out what's going on? Pardon? The condition of the while loop is while return code, so as long as scanf's not returning end of file, it keeps going around. Well, pretty obviously it's not returning end of file, but that's correct because it hasn't reached the end of file. It's at the point after the 2 point. So what could we do? Well, look at the return code. Let's look at that manual entry for scanf again. We probably should have read it more carefully. But we just decided, oh, good enough, let's go and read our program in. So where's return code? Return code. See if we see what, whoops, back. Function return the number of input items successfully matched and assigned, which can be fewer than provided for, or even 0 if an early matching failure. So if we tell it to read in something that's not an integer, and it can't successfully read it in, what value does scanf return? 0. Does that solve the mystery? Let's see. Our program gets here 2.5. We go return code not equal, it's 0. So we add 1 to the count, add it to the sum, print it out, do another scanf. Guess what that scanf does? Exactly the same thing as before. It's still stuck at the same point. It says, like, the scanf's there because we said 0.5 and the points can't be part of an integer. So it said, oh, I can't find an integer here. I'm returning 0. And then what do? We said, try again. And it says, well, I still can't find an int here. And then we said, try again. That's how we got an infinite loop. So what are we doing wrong? Well, it's the return code. Maybe we should just stop if we get something that's not an integer. That's the easiest thing to do. So we'll just write this test differently. So instead of testing for not equal to end of file, what does it mean? What will happen if we successfully get a new number? What will the code be? 1. So what we really want to do is, as long as we successfully read a number, and then we'll stop if we get end of file or they typed in some gibberish or whatever. I mean, maybe if we're really being a correct program at this stage, we'd check the input, and if it was gibberish, we'd put an error message or something. But we're just going to keep this simple. So that, I hope, will fix it. Let's try now. Average, and we're going to try 2.5, and there we go. As soon as we got to the point, it stopped. That's fine. Now, what other tests did people suggest? Sorry? 0 or nothing. Nothing. Everyone agrees. Let's do nothing. With nothing, we get straight out of the while loop. Count is 0. We can't calculate the average because there's no input values. And the assert fails and it says aborted. Is that correct? Well, not really. That's not what you're supposed to use assert for. Assert means if an assertion fails, it means there's something wrong with your program. And there wasn't anything wrong with the program. It's calculating the average correctly. It's just that we can't possibly calculate the average if there's no input numbers. So really, rather than having an assertion failed, we should test for count equals 0 and print out an error message. So this is really bad programming, but I'm not going to fix it up. Any other tests we want to try doing? Negative values. Yeah, maybe they will cause it to break somehow. -5. Oh, sum -5. Hey, this is cool. We can keep track of the sum as we go. 3, 12. That'll do. Averages. Works fine. So I declared my average program working, and I can go and tick that one off. Calculate average. The next thing says arrays. What's going on here? Okay. What I want to do is this one. Yes?
Can you put in a few numbers where the average is negative instead of positive?
Okay. It's just another test we should try. Let's test this thoroughly. Try average where the average is negative. -4, -3. Average is -3.5. Be cool? Yep. All right. So I want to write one that prints above average numbers. So the idea is just like average, except what I care about is from all the numbers I've typed in, I want to know which ones are above the average. Now, how do we program that? Well, if we start trying to do it, we quickly run into problems because we can't work out the average till we get down here, and then we have to go back through those numbers and print the ones that are above average, except we didn't save them. All right? Every time we read a new number, we replace CNum. So one solution would be to require the user to type the numbers in again. Probably not very user-friendly. What we want to do is we want to store those numbers. And the thing is, we don't know how many there are. There could be 10, there could be 100. We need some way in C of storing a bunch of numbers. And that's arrays. So my bullet points tell you all you need to know about using arrays pretty well. Here's a complicated example. So this just looks like declaring int test R, blah, blah. Oh, here's the bit that's different. You put a number in square brackets, and instead of giving you somewhere where you can store one int, I've given me somewhere where I can store 4 ints, one after the other. And if I put 100 there, I can store 100 ints. If I put 1,000, I can store 1,000 ints. And that's an array. All right. Initializing. We know what initialize. Yeah.
I saw the computing counting system so that it's 0, so you'd actually have 3 elements, so that there would be 3 to denote the number of elements in the array, so you have 0, 1, 2, 3, 4.
So that array, we're getting a bit in front of ourselves, is, well, let's draw a picture here. We put the numbers 42, 11, 1 and 7 in it. With that thing there, what we actually have what is it? 42, 11, 1 and 7. How do we refer to them? Well, this one here, we actually start counting at 0. That's the secret of C. C programs like to start counting at 0. So for an array, the first element of the array is actually element 0. So that's test array 0. This guy here is actually test array 3. Array declared a size 4, the last element is actually not number 4, but number 3. And that gives you 4 elements in the array. So you might notice the way you refer to things in the array, like that, kind of looks like the way you declare arrays. In other words, you put the name of the array and a number in square brackets, and that's how you refer to an element in an array. Shh, quiet. Everyone's talking. If you're confused, you want to ask something maybe. Everyone's talking about it. You had questions you wanted to ask about this? You can ask everyone. No? All right. So, here's my second line of how to use arrays. There it is there. That's all there is to it. Here's an array. I've got an array called A. I can use something like this just like any other variable. So I can use it on the left-hand side of an equal sign or a right-hand side. So I can use its value, I can change its value. So array element 0, that's the first element of the array, we make it equal to 2 times A of I. And this is why arrays are powerful, because I is another variable, it's an int. So depending on what the value of I is, I'll make it either the 2 times the 0th element or the first or an arbitrary number. And by combining this indexing into an array by a variable and a while loop, we can process all the elements in an array. All right, it's probably best just to see it happening rather than me talking about the ideas. So let's go and write my next program, which is going to be called above average. Average. .c, there it is. So input numbers that are above average. All right, so what we want to do is, the trick is to do this, we've got to save all the numbers as they're read in. And we're going to save them in an array, and going to be an array of ints, so we'll call it what, nums, and it's going to be an array, so we've got to put how big to make it in square brackets. And I've got to put a number here. Let's put 100 in. So our program has a limitation that it won't work for more than 100 numbers because we've only made an array big enough. Yes?
Is it necessary to define the length of the array?
Pardon?
Can you set an array without defining the length?
Yeah, not easily.
Okay.
So at this stage, we've got to pick a size for it. And we'll worry about. You can do fancier things, but we don't know about how to do that yet. Yes.
Is that like 100
It's 100 as in there's space for 100 integers in this array. Yeah.
I'm still not quite sure what return code does.
Down here.
Yeah,
So when you call scanf and you ask scanf to read in a number, the return code is how many things it was able to read. So return code of 1 means I successfully read in one number. And in this particular case, we're only trying to ask it to read in one number. So 1 basically means succeeded. And 0 means failed, or EOF also means failed, because it will mean it was trying to read it in and got to the end of file.
Right, so return code is already defined in the hash code itself?
Return code is defined, what it means is given in the definition of scanf.
Okay.
Is that, we good? Okay, so we've declared an array here. Just make sure everyone follows this. We've got room now for 100 numbers here. And as we read each number in, we're going to save it away in this array. So this is all looking good. I guess we don't need the printf anymore here. So cnum we're going to store in the array called nums. Right. I've left something out here. Let's start with that. We'll fix it up in a second. Well, that would store all the numbers in the same place. But what we want to do is store the first number in 0, the next number we get into position 1, the next number into position 2, and so on. So instead of putting a 0 here, what do I need to put? Count, yes. Count minus 1. Oh, right, because count starts at 0. We've just added 1 to it. Count minus... That's ugly saying count minus 1. What should we do to fix that? Move it up, yeah. So, store it in position count. Then we add 1 to count and update the sum. Add up the sum. And now we'll leave this in. We still want to print out what the average is. Now what we're going to do is, let's draw a little picture. Let's find the eraser. Here it is. So here's my array of nums. Count. Suppose count is 4. I've read in 4 numbers. Array with nums, well, there's nums 0 would be the first one, nums 1 would be the second one, nums 3 would be the third one, nums 1. So now what I want to do is I want to go through this array and all the ones that are bigger than the average, I'm going to print them out. I need another while loop. So, while, and I've got to keep track of where I am in this array. So I'm going to use the counter, and by convention, you'll see this used lots of time. We just use the letter I because it's just an index into the array. So I for index. You don't want to use a long name because you'll find yourself using this lots and lots and lots. So your program's actually easier to understand if you use just a short name for it. Yeah.
Count 3 because we're doing 4 elements. And it counts the increment.
No. After we successfully read an element, we add 1 to count. So count is the actual number of elements we've read in. So count will be 4. Pardon? It starts at 0, but look at the code. After reading 1 number, we add 1 to count. So count will be the number of things read in. Oh, more questions? Yes?
Could we just count down from what count is up to? Use count and decrement in the while loop?
Yeah, we could do it that way. Then they come out backwards though.
It's not in the spec.
It's not in the spec. Yeah. So my spec's probably a bit vague, but you're right. We could say, hey, we could do them backwards. I'm going to try to do them forwards though. So
If you did what, they would come out backwards?
if we started, instead I'm going to declare it, I'm using a new variable here called I to keep track of where I am when I'm going through it. He said, well, you could just reuse count and just count down. And then you'd put them all out, but they come out in reverse order. Okay. So here's my variable. It's going to be called I to keep track of where I am in the array. Some sort of test here. We're going to come back to it and see if we can figure out what it should be. And now we're going to be if, here's the key test, if nums of I is it bigger or smaller? Greater. If it's greater than the average, which we're just stealing from up here. How does that look? So if it's bigger than the average, make it double. Do we need to make it double? Okay. So what should it be, a double or? Oh, look, just leave it like this for now. We'll fix it up later. This is a bit messy, but it's shorter. So let's get to printf. Printf. I should separate it.
Yeah, with a new line or a comma or something.
Yeah, probably. I need a new line after printing it, don't I? There we go. All right, so that's the basic idea of my loop. We're going to go nums I, but we're still not finished. Loops, really this should be up here. Loops have to be initialized. So there's the initialization of I equals 0. The test is now, when I equals 0, we'll get this one. I equals 2, 1 will get this one. I equals 2, I equals 3. What's the test? When do we, on the, I is less than count. Or should it be less than or equal to? Okay, let me think about this. Classic Fent post error. Is it less than or less than? You really often have to make this decision. Oh, geez, which should it be? Okay, think about it. If we made it less than or equal to, the last time around this loop, we'd have count equal to 4, and we'd look at nums index 4, but 0, 1, 2, 3, 4 is here, right? That's the 5th element of the array. We didn't store anything there. It'll just be random numbers in there. So the correct test is that one. All right, should we try running that now, see what happens? Oh, you guys are way more alert than me. When we're writing loops, initialization, test, update, we haven't added 1 to I. This is an infinite loop we've written here, because I never changes. So we've got to add 1 to I. All right. So it's now called above average. Above average. Above average. Ooh, I'm always surprised when you do that and it doesn't complain. I guess it helps get all these extra, because when I was doing it on my own last night, it took me about 6 goes before I got it right. With 100 people looking at what I'm writing, it's going much better. All right, so above average. And we go 3, 7, 2, 1, 9. All right, 0. Average is 3.6667, and 7 and 9 are the ones that are above average. Pretty cool. Now, people have already pointed out there's all kinds of dodgy things about this program. Really, I shouldn't be calculating the average over and over again. Anyway, I don't think that's important. But the other thing that maybe concerns me is the average is a double. I'm doing it as an int. Did it matter?
Not there.
Not there. Can you think of an example where it would matter? Pardon? 3 and 4. Let's try it with 3 and 4 and see if it makes a difference. Oh, it worked. 3, 4, 5. 3, 4, 5. Yeah.
Matter if you were calculating the average if the inputs was double as well.
If the inputs were double, well, this only works if integers, because we're reading in integers and storing them in integers. So yeah, if we could rewrite this whole program and store an array of doubles, and total, sum, and cnum would also be doubles, and everything would work as a double, and we get, I guess the program should still work. Yes?
Try it with 42946 7297.
You're going to have to repeat that. So what do you want me to type in here?
429467.
429.
467.
4. Is it next number or?
No, it's the same number.
This is still the same number, is it? A really big number.
297.
297. Like that?
And then whatever.
1 or just that number on its own?
1.
And 1. What's the average of those two things? I don't know. What is it? That seems to work. What did you think would happen?
I was trying to see if I could get a number larger than
Larger than int would handle. Well, that isn't it. Because ints can be bigger than that. It's only 429 million. Didn't Richard do biggest int? What was the biggest int? Pardon? I didn't know the digit on there, yeah. Yeah, I mean, if we use numbers that are bigger than int, something bad's going to happen. Just want to be mean to my computer. So 1, 1, 2, 3, 1, 2, 3, 1, 2, 3. It can handle that. Now we'll do it again though. And do it again. I think that's probably going to cause it to be unhappy. Yeah. So the average is minus a really big number. And it says, well, they're all bigger than that. And the reason for that is with ints, once you get past about 2 billion, it wraps around and it turns into a negative number. So if you really wanted to have this work properly, and those were the sort of inputs you're going to use, you should use doubles. Because doubles don't have that problem. They don't wrap around when they get too big. Yeah.
Why don't you just use the doubles anyway?
Why not use doubles anyway? Doubles have their own problems in that arithmetic on doubles is not exact. It doesn't really matter here, but you can sort of add 3 numbers together, add the same number to itself 3 times, divide by 3, you don't get back the original number. So calculations with double are only approximate, which means when a lot of stuff that you need to do with doubles, you've actually got to be a bit more careful about your programming. And rather than testing for things being exactly equal, you've got to test if they're approximately equal. So usually it's simpler to work with ints unless you really do need this sort of thing. All right. Let's go to... yeah, so talk amongst yourselves for a bit.